Hey guys, and welcome back to my CCNA 200-301 course. Patrice is here, and in this video we are going to configure an extended IP version for access list. Are you ready? Let's get started. This is our today's scenario. PC1 and PC2 are in subnet 192.168.3, 3.1 and 3.2. And this is my personal machine that I'm running a web service and also FTP service on it. So my computer is listening on port 80 as well as 21. And in this video, I'm going to show you how you can granularly restrict your traffic or filter your traffic based on TCP ports that are listening on this computer in compared to a standard access list that you only would be able to restrict your traffic based on source IP address only. Before configuring the ACL, I want to show you both PC1 and PC2 are able to talk to port 21 and 80 to 192.168.1.210. So I'm using same commands as the previous video. Ping 192.168.1.210. -3 means it's a TCP ping, and -p means the port number is 21. And as you can see, PC1 can talk to that IP address on port 21 and also on port 80. So the communication is establishing between these two machines. And I'm going to run the same tests on PC2. So ping on port 21, which is okay, and also on port 80. And as you can see, the communication is establishing. So PC1 and PC2 can talk to ports 80 and 21 on server 192.168.1.210. I want to write the ACL on router 2. So I go to router 2 global configuration mode and we start our access list definition, which is access list like the previous video or standard access lists. But this time we have to use a number within 100 to 199 or 2000 to 2699 to let the iOS know that I'm going to write an extended access list. Now we have the option like a standard access list to deny or permit or remark. Okay, this time I'm going to use deny because I want to prevent PC1 to access port 21 on 192.168.1.210. In front of deny, this time we have some options to mention what protocol we want to match for this ACE. And for this case, I'm going to use TCP because we are going to test our connectivity to TCP port 21. So I mentioned TCP here. And now in front of TCP, I have to mention what source address, which can be a specific subnet or IP address, or it can be any. So it's up to you. If you want to allow or deny a specific traffic from everyone, you can use any. Or in this case, I want to say TCP host because it's an individual IP address. I would say host 192.168.3.1. And now I have two options. First, to mention the destination IP address or any as the destination, which means from this host to any destination, or I can determine some operators to match the source port number. These operators are equal, greater than, less than, not equal, and range. So you can say if the port number, the source port number is equal to this number, greater than this number, less than this number, not equal to this number, or within this range. Okay? Since the source port number for TCP connection is going to be something higher or bigger than or greater than 1024 based on what we talked about in TCP and UDP video, here I can use greater than 1024. If you don't put it, that's fine. It's just for demonstration. So you can see what options do you have. And now when we mention everything about the source, so the source address is this one and the source port number is this one. Now it's time to mention the destination, which can be one IP address or a range of IP addresses or a subnet or it can be any. This time again, since I'm going to use a specific host address, I'm using host, which is more descriptive. And 192.168.1.210 as the destination. And now we have the options for the destination port number, which in this case, it is equal because I want to prevent access to port 21. So if I put equal here, I have some options. There is a list of protocols that you can use here. And if the protocol that you want to allow or deny is not listed here, you can still use the port number, okay? But if it is something amongst these things, you have the options to use either the port number or the name. So in this case, I have the option to use FTP keyword or just use the port number 21. Both work. In real world scenarios, since FTP uses both port 20 and 21, you have to add both of them because FTP.data is using for the data transfer, FTP port is using for authentication. But in this case, since I'm just gonna test my connectivity on port 21, I'm using FTP. So this is the destination. This was the source and the source port number, and this is the destination and destination port number. And I have one option here I want to talk about, and that option is log. Okay, if you add log here, which you can add it to a standard ACE as well, this will generate syslogs when the traffic matches this ACE. And also, so you can see it in the syslogs. And also, if you run show access list or show IP access list in the future, it will show you occasional statistics about how many hits this specific ACE had so far. So you can figure out if that ACE actually hit or not. So if the number is 0, that means that the traffic doesn't match that ACE that's supposed to, and you're expecting that. So you can start your troubleshooting why actually this traffic doesn't match that ACE, etc. So this ACE gonna deny PC1 to access port 21 on that destination. But I want to allow this PC to access port, so I'm changing this to allow, and I want to allow it to access port number 80 on that one. Okay, so with these two rules, sorry, permit, not allow, permit. So with these two ACE, 192.168.3.1 will not be able to access port 21 on this host and would be able to access port 80 here. And I want to do all the way around on PC2. So I want to deny PC2 to actually not allow. I want to deny PC2, which is host 192.168.3.2, to access port 80 on that one, and all the way around port 21, and then come back here and change this to permit. If we leave the ACL like this, then if there's any other PC that wants to try to access anything, then they won't be able to. And also, how I wrote this ACL is not recommended. You saw that I added one allow. Let me show you again. If we say show access lists, you can see that the first line is deny, the second line is permit, the third line is deny, and the fourth line is permit. Okay, but this is not recommended way of writing the ACLs. So either start with denies and then add your permits if it doesn't match your strategy about the filtering, or all the way around. Start the permits first and then add the denies at the end. Okay, so this is the recommended approach to write the ACLs. So if this is the only thing you want to restrict, and then you want to allow other hosts to access anything else, then it is normally we add a general rule to allow the rest of the traffic. So at the end of this, we are going to say access list 100 and then IP from any source to any destination, okay? And then log. So, access list 100 permit and then IP any in, okay? So this rule will allow everything else to go through and just filter these two circumstances that we want to apply. It's time to apply this ACL on the interface or desired interface. In this case, again, I want to apply this access list on this gigabit Ethernet 0/0. So I go to gigabit 0/0 and I'm going to say IP access group 100 and then on incoming traffic. It's time to verify our access list function. I added the router to console here so you can see that log impact on the syslog behavior. So I'm going to PC1 and on PC1 I am expecting to be able to access port 80 because I allowed that. So as you can see, the communication is fine. And you can see a log here, access list 100 permitted TCP 192.168.3.1 from this source port to 192.168.2.210 on port 80, one packet, and this is the syslog for access list. And if I try to access port 21, you can see that the communication is prohibited and the log shows that access list 100 deny TCP from this source address, this IP, this port number to this IP address, this port number. And if I run show access lists once again, you can see that there is some statistics here. 3 matches, 27 matches. But these two doesn't have any match. But as soon as I actually try to use the similar commands on the other one, this one, you can see this time port 80 is prohibited and you can see the deny log here, and 21 should be okay, and you can see the logs here permitted. And if we run show access list again, you can see these two also have matches. The last thing I want to talk about in this video is the placement of the access lists. I mean, what is the best practice to apply the standard and extended access list? I intentionally added the standard access list close to the source to show you one thing and show you this is not very good, because if you add your standard access list close to the source and, for example, deny PC1 to access any destination, then this PC will not be able to go even one hop after this router, which might not be very useful in many circumstances. This PC might be able to access internet, for example, but not a specific server. But if you deny that PC through a standard access list and apply that access list close to the source, then it's going to be useless. So practically, it is recommended to add a standard access list as close as possible to destination. Okay, so for example, in this scenario, for a standard access list, it is recommended to apply it on the outgoing traffic of this interface, for example, which is not good because at least you're gonna use the bandwidth between these two routers for an unwanted traffic. But this is how it is if you want to use a standard access lists. But in contrast, since extended access lists are very granular, you can apply them as close as possible to source, because you can granularly restrict or allow the traffic. So it is gonna be help you to use your network links with a very optimized situation. So you don't take the unwanted traffic all the way to the destination and then deny it here. You deny it as close as possible to the source, and then this will help you to use your network bandwidth in an optimized way. So your key takeaway from this note is, for a standard access list, write them as close as possible to destination. This is what is recommended. But for extended access list, it is recommended to apply them as close as possible to source. Alright guys, this was our today's video. We are still covering exam topic 5.6, configure and verify access control lists. In the upcoming video, I'll be talking about named access list. I wish you enjoyed today's video and see you in the next ones.